All right, everyone. Welcome back. Hope we had a good morning with Math 161. This is MDE 61, our third week, first day. So we're going to spend more time factoring today. We might be spending more time factoring next class as well. Like I said, we're going to spend a decent amount of time practicing this stuff. We're still introducing techniques. So far, we introduced all of the three formulas for difference of squares, sum of squares, and difference of cubes, the binomial formulas. We introduced how to factor out GCFs, and we introduced what I call the shortcut method. I said that there are other methods for trinomials, things like the box method, et cetera, et cetera, et cetera. If you learn those on your own, feel free to use them. I have no problem with that, as long as you're able to factor in whatever way you can manage. That's the ultimate point. So today what we're going to do is we're going to practice a couple more with the shortcut method, but maybe with something else paired with it. Then we're going to get into what I call factor by grouping, which is actually 4-term polynomials. Then we'll go back to the 3-term polynomials and do something that I call the AC method. Some people will actually call it factor by grouping as well, because that 4-term polynomial method is involved in the 3-term polynomial when you have this particular condition. All right, so that being said, just want to remind us what the shortcut method is, which is only applicable for trinomials where the leading coefficient is 1. There's no number in front of the x squared. It's you take the number at the end, including its sign, and you list the pairs of numbers that multiply to make that pairs. So if it was, say, at 12, 1 times 12, 2 times 6, and 3 times 4. And out of those pairs, you either add or subtract based on the sign of that number you just split up, add a positive, subtract if negative, and try and make the middle number, what we call the b here. And not just the b, but you have to include its sign as well. You have to make it an appropriate positive or negative. And that's how you choose the signs of the two numbers that go in the factored form. The shortcut is it goes x number, x number. This is where the shortcut is. When we get to the AC method, it's going to take more work to get to that point. And then we did several examples, so I'm not going to rehash them. Let's start with an example 1. A couple of these. For A, let's go with an x. I don't think that's there. Oops. I just need to click somewhere else. Let's go with an x squared here. Go with a minus 16x and a plus 16. So x squared minus 16x plus 60. 3 terms, 1, 2, 3. And there's no number written in front of the x squared, which means we can use the shortcut method, hopefully. Remember, not all polynomials are factorable. Sometimes they're prime. Sometimes they can't be factored. So if you can't find a pair of numbers that multiplies to this, but then adds or subtracts to that, then it's prime. So what do we do? To the side, I'm going to write that plus 60. Write all the numbers that multiply to 60. And this one's got a decent amount of them, so I'm going to try and go in an order where I go 1 times 60. And then does 2 go into 60? Yes, it does. 30 times. Does 3 go into 60? Yes, it does. 20 times. Does 4 go into 60? Yes, it does. 15 times. Does 5 go into 60? Yes, it does. 12 times. Does 6 go into 60? Yes, it does. 10 times. That's how I can get my products really quickly and easily. Does 7 go into 60? No. 8, no. 9, no. 10, yes. But we already did the 10. It was 10 times 6. So that's how I know I'm done. If I don't go in an order, I might miss the 3 and the 20. I might miss the 5 and the 12. It's easy to miss something. Now we're trying to figure out which of these pairs adds, because that was a plus, to make this 16. So you add the pairs. That would be 61, 32, 23, 19, 17, and 16. Boom. 6 and 10 add. Make the appropriate value of 16. But it's not just a 16, you have to consider the sign. It's negative 16. So these will both need to be negative to take a negative 6 plus a negative 10 to get a negative 16. Remember I said you have to be on point with your arithmetic sign rules. If you're not, go back and brush up on your own time. Definitely not teaching that at this level. Same sign, add the numbers, keep the sign, different sign, subtract the numbers, keep the sign of the larger. There, I just taught it for Math 161. And then what do we do from here? It's just x minus 6 times x minus 10. I could swap the order of the 6 and the 10 if I want, as long as the signs are appropriate. But that's all we do. I do this. I wish I could move that. That's all right. That's all right. Oops, something on my board. So we did that one quick because it was basically a review of last time. Let's do another one. Let's do a 6x squared, then a minus 18x, then a minus 60. That's an ugly 8. Let's try again. 6x squared minus 18x minus 60. And you go, but Mr. Beckner, you just said we can't use the shortcut method on this because the leading coefficient isn't a 1, and that's the whole way we use the shortcut method. Ah, good observation, but that's not the whole story. Remember that whenever you're told to factor something, the first thing you should always look for is a GCF, and in fact, there is a GCF here. I can't take any x's out because this term doesn't have any x's. I can't take something that's not there. Out of the 6, the 18, and the 60, 2 goes into all of them, 3 goes into all of them, but we can do a little better. 6 goes into all of them. So there is a GCF of 6 that we can pop out. So we write the GCF first, we open a single parentheses, and then we just divide each term by 6. 6x squared divided by 6 is x squared, minus 18x divided by 6 is 3x, then minus 60 divided by 6 is 10. Now inside here, there's no number written in front of the x squared, which means we can shortcut this if it's factorable. Now, if for some reason the inside was not factorable, we wouldn't call this whole thing prime because we still took a GCF out. So to the side, what do we write? We write the minus 10. Factor pairs of 1 times 10 or 2 times 5, not a lot of options. Now, because that's a minus, we're supposed to subtract to try and make a 3, specifically a negative 3. We'll get there in a minute. 10 minus 1 is 9, 5 minus 2 is 3, so 5 and 2 are the choice. But we don't want to choose a positive 5 and a negative 2 because that would subtract to a positive 3. We're supposed to make a negative 3, so we need to go positive 2 and negative 5. These can't be the same sign because then we'd be taking negative 2 and negative 5, and that would make negative 7. Or positive 2 and positive 5 would make positive 7. Giving us final answer. Leave the GCF in front, x plus 2 times x minus 5. How about x squared plus 4x minus 16? One last one before we move on. So no GCFs, go to the side, you write a minus 16. Split them up, 1 times 16, 2 times 8, or 4 times 4. Find the pair that subtracts to 4. 16 minus 1 is 15, so that's out. 8 minus 2 is 6, so that's out. 4 minus 4 is 0, so that's out. Uh-oh. Uh-oh. None of the options work. That's what I was mentioning a few minutes ago. When none of the options work, it's not factorable. It's prime. There's no way to use whole numbers to write this as some x plus a number times x plus a number, or x minus a number times x plus a number, et cetera, et cetera. What's interesting is if I were to just randomly generate 3 terms with x squared x and a constant, there's like a 97, 98% chance it's prime. So we really have to think and make sure when we generate these to make sure they're factorable. We have to think about it in advance. All right, so that's our shortcut method for trinomials when the leading coefficient is 1. You might need to practice this 100 times. You might prefer another method, whatever works for you, but get it done on your own time. All right. So factor by grouping for 4-term polynomials. So this is when you have 4 terms, not 3. All 3 of these examples had 3 terms. So there would be an extra term, maybe an x cubed up there. Or maybe 2x terms or 2x squared terms. You can have terms that could have been combined, but maybe it's just better to leave them that way. We'll get to that later. So what do we do? And again, this method is going to be needed for the AC method later. You take a GCF from the first 2 terms. So you're going to mentally split this thing in half. So first 2 terms, second 2 terms, split them in half mentally. You're going to take a GCF from the first pair, from the first 2 terms. Then what you're going to do is also take a GCF from the last two terms. But because of the way you have to write things, you're going to need to take out a sign. Maybe a plus, maybe a minus, but you're going to need to write the sign no matter what. Kind of like when we were splitting up the constant above in the blue ink. We wrote the minus, we wrote the plus. Now, when you take out a minus, that means those signs are both going to change. We'll have to be careful there. We will, of course, see examples involving that. So GCF from the first pair, GCF from the second pair. Now, what you're going to hope happens is that those parentheses match. You might have an x plus 2 in a parentheses and an x plus 2 in a parentheses. And that's being multiplied by something else in this polynomial. And that's the whole point of GCFs, is that something is a product of something else, and you see it in multiple spots. So if you see this parentheses in a first spot and you see this parentheses in a second spot, that means it's actually a GCF. It's a third GCF. It just looks a little goofier because it's got two terms, but it's still a GCF. So guess what you do? You take that out. So if the parentheses match, you take out that parentheses as a third GCF, and then what goes in the other parentheses is basically just everything else you see. You cover up the parentheses from the line above, and that's exactly what goes in the next one. GCF, GCF, goofy GCF. Again, GCF, GCF, goofy GCF. Example 2. Guess what these instructions are going to be? One word, factor. Let me just take all this down. Hey. My favorite first example, x cubed plus 2x squared plus 4x plus 8. Nice little pattern to it. GCF, GCF, GCF. Why? Because there's 1, 2, 3, 4 terms. Are there other factoring methods for 4-term polynomials? Absolutely. Are you going to need them in this course? No. They can actually get pretty crazy. We're not going to use them. So the first GCF, and again, a lot of people will actually write a little line here, splitting this thing in half, or a squiggly line. I'll do it, but I'm going to erase it because I don't like it. It's just not for me. But that's what we're doing. We're only thinking about the first two terms, and then we're only going to be thinking about the last two terms initially. So for the first GCF, between x cubed and x squared, there are 3 x's here, there's 2 of them here, so we can take out 2 of them. Can't take 3 because the second one doesn't have 3. For the constants, a 1 and a 2, I can't take out anything because there's nothing that divides into them besides 1. All right, so here's what we do. We write the GCF, we open up parentheses. Oops, that was supposed to be in blue. And then we divide each term by the GCF. X cubed divided by x squared is x. Positive 2x squared divided by x squared is a plus 2. See, I'm only taking it from the first two, which is why I've gone ahead and closed the parentheses. Now for the second GCF, we're looking at the 4x and the 8. But I've said you're going to have to take out a sign with that second GCF. There's lots of little bits of memorization. Be careful with here. So even if it's positive, write a positive. 4x and 8, I can't take any x's from 8, but I can take a 4 from both 4x and 8. So that GCF is a positive 4. These are both positives, so take out a positive. There's no reason to take out a negative. Maybe there's a reason to take out a negative later. We'll get into that. So plus 4, open a parentheses. 4x divided by 4 is x. 8 divided by 4 is 2, so plus 2. Hold on 1 minute. Sorry about that. There was a lot of noise in my room that was extremely distracting. I had to take care of it. And I don't think I've taken care. All right, well, I'm going to do my best. So third step, if the parentheses match, x plus 2, x plus 2, huzzah, they match. So what do? We say that our third GCF, hold on, working from home, I swear. All right, so our third GCF is going to be x plus 2. Notice I leave it in a parentheses. Do you have to have it when you write this to the side? No, but it's going to be helpful for when you go down here. So what do? Well, whenever we take a GCF out, that's the first thing we write. So I'm going to write the GCF first. So that was this and this. Now I'm taking these away from the terms. I'm dividing it out. So they're not going to be sitting there anymore. So here's the GCF. Then we always open a parentheses and we write what's left over. So here's what you do. You're going to take your hand or your pencils or whatever. Don't erase these permanently. Don't scratch them through permanently. I'm just saying, cover up the thing you just took out. So we took out the x plus 2. Cover all of those up, the GCF, and that, whatever you see after that, is what goes in the next parentheses. So when we take it from the first term, we're left with this x squared. When we take it from the second term, we're left with this plus 4. So this second parentheses will be x squared plus 4. So again, you just cover up the GCF in the line above, and whatever you see left over is what goes in the second parentheses. So x squared, that was from this one. And then plus 4, that was from this one. And that is our answer. I'm just going to write this in one single color because it looks like a rainbow for now. Nothing wrong with rainbows. Those are awesome. You're like, oh, x squared plus 4 is factorable. No, it's not. That's a sum of squares. That's a plus. If it was a minus, you certainly could, but it's not the case here. B. Let's go with x cubed minus 5x minus, minus 5x squared minus 20x. I'm sorry, I've got that wrong. I'm all over the place. Let me start that over. Writing the x squared threw me off. Minus 4x, and then we're going to go with a plus 20. So our first GCF, there's 4 terms here. Between x cubed and x squared, it's going to be x squared again. Our second GCF, the GCF for the last 2 terms, between 4 and 20, it's going to be a 4. Now, I'm going to hold off on writing the sign, the plus or a minus. I'm going to write a sign here in a little bit, but I'm going to hold off for just a second. And I'm going to verbally give you a tip that maybe you want to write down after this. So, equals. When I take out the x squared, divide it out, you'll be left with x minus 5. X cubed divided by x squared is x, minus 5x squared divided by x squared is just a 5. Now let's try something. I'm going to try something, okay? And I'm going to spoil this. This is going to be wrong. Let's try taking out a plus 4, okay? If I take out a plus 4, I'm doing negative 4x divided by positive 4. See, these signs play an important role. Negative 4x divided by positive 4 is negative x. And then positive 20 divided by positive 4 is going to be positive 5. So plus 5. Now the third step says the parentheses are supposed to match. That's x minus 5. This is negative x plus 5. There's no match here, which means we haven't done anything appropriately. We're close, actually, because we got an x, we got a 5, but the signs seem to be backwards. So that should be a signal to you to, instead of say, oh, I shouldn't have taken a positive 5 out, I should take a negative 4 out. Excuse me. I said 5, I meant to say 4. That second GCF is actually a negative. So when I take out a negative 4, that's going to make things line up. Now, I knew instantly to take out a negative, and I'll tell you why after we write this. Now let's try this. Negative 4x divided by negative 4 is positive x. Positive 20 divided by negative 4 is a negative 5. And boom, we have matching parentheses. So our third GCF is the parentheses that matches x minus 5. So what do? We write that x minus 5, the thing we're taking out. We open a parentheses. And then what goes after that is, well, just cover up with your hands or whatever the GCF you were taking away, and you're left with x squared minus 4. So this is x squared minus 4. Now, if you box this up and ship it out, guess what? You're wrong, because there is now a difference of squares in x squared minus 4, where your a would be x, and your b is 2. So this becomes x minus 5, leave the first one alone, times x plus 2, times x minus 2. That is the answer in all its glory. Factoring can be 1 step, it can be 30 steps. You never know. Depends on how the problem goes. I said I wasn't going to write it, but I will. Here's a tip. The sign, second CF, match, third. So I instantly knew to take a negative out for my second GCF because that was a negative. If this had been a plus 4, I probably would have needed to take out a plus 4. This is true 99% of the time. Because sometimes it's not factorable and there's your 1%. Now, there's a possible case where all 4 of these terms have a GCF between everything. So just like the previous problems, if you see a GCF between everything, pop that out first. I'm not going to do an example with that, just in the interest of time. Be on the lookout for it. Let's some space. I just want to pop this back some. All right, time for the big guns. Back to trinomials. So we're back to trinomials. 1, 2, 3 terms. Sorry, just trying to keep the example on the screen at the same time. Back to 3 terms. But now, instead of the first term just being an x squared, there's this a in front of it, which means there's a number in front of it. So even after taking out any GCFs, it's still a 3x squared or a 5x squared or a 10x squared or a negative 29x squared, whatever. So the leading coefficient is not a 1 now. The number in front of the leading term is not a 1 anymore. This has a couple different names. Some people call it factor by grouping, but I just like to give it a slightly different name. from the 4-term method, but it does involve the same method eventually. Because what we're going to do is take this 3-term polynomial and mathematically turn it into a 4-term polynomial. We're going to split the middle term into 2 terms, and that's okay. We're going to take something like a 5x and turn it into a 2x plus a 3x, or a 6x minus a 1x. But we got to figure out what those numbers need to be through a process. And the process is going to feel similar but different to the shortcut method. Now, there is an alternative method for this, something completely different. It's called trial and error. You saw me do an example of that in 161. I am not sure. I will introduce trial and error in here, but I don't know how many examples I'm going to do, because while it is a great method, you really have to do dozens and dozens and dozens and dozens, if not hundreds, to really perfect this technique. And even still, you can go down a dead end 20 times before you get it right on the 21st try and be a master at the method. Whereas the AC method is very, very consistent once you master the method. There's not 20 dead ends to it. So what's this process? Take the A, which is the leading coefficient, the number in front, and multiply the C, which is the number at the end, the constant. So we're taking A times C. A times C is AC. So you don't need to say times with variables. And that's why we call it the AC method. You're going to take the leading number and multiply it by the ending number in addition to other signs. So that could be positive, that could be negative. And you'll write it down just like we did with the first step of the shortcut method. Now, instead of just writing factor pairs of the constant, you're going to write the factor pairs of this new value, this A times C. List the pairs of numbers that multiply to make this AC value, but then add or subtract to make the B. This is practically the same step as the shortcut method. It's just we multiplied something first to get the value we're splitting up. Again, step 2 feels almost identical to the shortcut method. And in fact, it is identical, because with the shortcut method, the leading coefficient's a 1. If you take 1 times the constant, you just get the constant. How about that? And then you still give these 2 number signs based on adding or subtracting the sign of B. Exactly the same as the shortcut method. So step 2, step 3, identical to the shortcut method. But here's where things get crazy. Not crazy, but different. Step 4, you don't just shortcut straight to the answer. You have to split the middle term, what we call the BX, into 2 terms. And those 2 terms will have coefficients based on the numbers you picked by the end of step 3. So instead of the 2 numbers being what goes in your parentheses with their signs, it's what goes in front of X or Y or XY, whatever that middle term is, when you split it up. So that's how we'll tell that the 5x turns into a plus 2x and a plus 3x, or the 5x turns into a plus 1x and a minus 6x, based on the pairs that multiply to this and add or subtract to that. Why are we doing this? Because you're going to make a 4-term polynomial. This is what you will have created. And I guarantee 100% of the time, if you were able to make it this far and everything's correct, you will have a 4-term polynomial that is guaranteed to be factorable by grouping. And I say C below, but it was actually C above in the instructions before. And this reorder. GCF, GCF, GCF. So you have a method in a method. Woo, buddy. So make sure you got all this written down. Make sure you practice this. Once again, if you hate this method, if you know trial and error, go with it if it works for you all the time. If you know the box method and it works for you, go with it all the time. I'm not teaching box method in here. If you know push and pull, go with it. I'm not teaching push and pull in here. If you know some method that your teacher taught you called something different, which is honestly just a veil of probably one of those 4 methods, go with it. I don't care how you factor as long as you can factor ultimately. But I will focus on the techniques that I go over. And if you don't like them, then go to the internet and find something that I hope you do like. If you don't like any of them, you're gonna have a problem. You just need to find one that works for you. Practice, 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 practice. No one got good at the cello after one day. I can guarantee that. Okay, so let's show you an example I had typed up for the factoring notes, and then we'll do one on our own. And I'll show you the little side steps along the way as well. So for example, 5x squared minus 16x plus 3. You would take the 5 and you would multiply the 3. Positive 5, positive 3, which is positive 15. That's a positive 15. So I would say to the side, your A times your C is the 5 times the 3, which is a positive 15. Then you list its pairs, 1 times 15 or 3 times 5. Not a lot of options. And you're trying to find the pair that adds to make 16, to make this negative 16. 3 and 5 add to 8, 1 and 15 add to 16. So, well, we choose the 1 and the 15. Again, this feels exactly like the shortcut method so far, except we did a quick multiplication to get the number instead of just take the number at the end. Then we need to give these signs to make a negative 16, so it's got to be a negative 1 and a negative 15. So I just finished step 3 up here. But I'm not going to say the answer is x minus 1 times x minus 15. If I fold that, we would not get 5x squared minus 16x plus 3. I guarantee it. What we do is we split this minus 16x up into 2 terms using the minus 1 and the minus 15. That's what is here. See, I left the 5x squared alone. I left the 3 alone. With this negative 16x, I made 2 terms. And if you recombined them, you would get the same thing. Negative 1 minus 15 is negative 16. But don't recombine them, then you're just going in a circle. We have a 4-term polynomial that I guarantee you can factor by grouping, and that's what the rest of this says. The GCF of the first 2 terms between 5x squared and 1x is x. When you take that out, you'd have a 5x minus 1. That's right here. Between the minus 15x and the 3, the second half, the GCF of the last 2 terms is 3. But remember I said this sign will tell you whether to take a positive or negative out. So we're going to take a negative 3 out. GCF the second pair is a negative 3, and that's what we get here. When you divide that out, negative 15x divided by negative 3 is positive 5x. Positive 3 divided by negative 3 is negative 1. And then I guarantee parentheses will match 5x minus 1, 5x minus 1, as long as you've done everything right. So that's where this goes. And then what goes in the second parentheses, just mentally cover up the 5x minus 1 and the 5x minus 1. And you see x and a minus 3, and that's what goes in the second parentheses. Now I know I'm kind of covering a few things up, so let me undo all of my coloring. And give you a minute or 2 to write that down. Don't worry, we'll do the rest of our examples in a much more normal fashion. I just wanted to cover the one that was typed up. Okay. We go to example 3. And once again, I'm just going to take the instructions and I'm just going to copy them down here so they can still be seen on the screen. For A, what do I have here? 2x squared. That is minus 16 at the end. And then this is a plus. No, I don't want that. 33. No, I'm sorry. Sorry, my piece of paper got pushed aside. 31, yeah, 31x. X squared plus 31x minus 16. And yes, that's the example I had. Now remember, I want you to get in the habit of first thing whenever you factor anything, the first thing is ask yourself, is there a GCF? And no, there isn't. Doing that really quick. Then you go, all right, how many terms do I have? 1, 2, 3. All right, well, so far we got shortcut and AC method. That's a 2, so we can't shortcut it. We got to use this full-blown AC method. So to the side, I write what A times C is. That's a positive 2 times a negative 16, which is a negative 32. And then we write all pairs of numbers that multiply to 32, which would be 1 times 32, 2 times 16. 3 won't go in. 4 would go in 8 times. 5 won't go in. 6 won't go in. 7 won't go in. 8 will go in 4 times. That's our repeat, so we're done. Then this sign will tell us whether to add or subtract the pairs. We're subtracting. 8 minus 4 is 4. 16 minus 2 is 14. 32 minus 1 is 31. We're trying to make this 31, so boom, 1 and 32 work. But we have to, step 3, give these two number signs to make sure they combine to make a positive 31, not a negative 31. So the bigger number has to be positive, the smaller needs to be negative. They have to be opposites because we're multiplying to make a negative. If they're multiplying to make a positive, they'd be the same sign. Those sign rules will really help you out here. Now, I do not say the answer is x minus 1 times x plus 32. That would be the shortcut. That would be if there's no 2 in front. We have to do 2x squared minus 1x. You don't have to write the 1, but I'm being illustrative here, plus 32x minus 16. So I took the 31x and I split it into 2 terms. And if you were to recombine them, it's the same thing. Negative 1 plus 32 is 31. But don't recombine them. So that was us splitting the middle term. Split the middle term into 2 terms. Now we have a 4-term polynomial that, again, I guarantee if you've made it this far, you can factor by grouping. So we're going to take a GCF from the first pair. Remember, we're mentally splitting this thing in half. For the first pair, the GCF between 2x squared and x is just an x. 2x squared divided by x would be 2x minus 1x divided by x is 1. See, that 1 would be helpful there. If you didn't write it, you might miss that. You might say it's just 2x, and that would be wrong. The third term's sign, the term that's basically the sign basically in the middle of this thing, tells us what to take out here. So take out a plus. The GCF between 32 and 16 is going to be 16. Open up parentheses. We're dividing by a positive, so no sign changes. 32x divided by 16 is 2x. Negative 16 divided by 16 is a minus 1. And look at that. 2x minus 1, 2x minus 1, they match, making it a third GCF. So what do we do? I'll show color. That and that is the GCF. We write the GCF first. Then we open up parentheses, and whatever was left over, remember mentally physically use your hand to cover those up, is what goes in the next parenthesis, x plus 16. X came from this one. The plus 16 came from the second one. I'm just going to rewrite it in one color. If you don't trust this, you can FOIL to check, just like before. This is kind of a crazy technique, so I will do this for once. Just going to check it really quickly. Let me get a different color, in fact. So your F would be 2x times x, that's 2x squared. Your outer 2x times 16 is a plus 16x. I'm sorry, 2x times 16 is not 16x, that's 32x. Pardon my, what's going on with my pen? 32x. What in the world? What are you doing to me, pen? Negative 1 times x is a minus 1x. Negative 1 times 16 is a minus 16. You have like terms in the middle. 2x squared plus 31x minus 16, and it works. About 25x squared plus 10x plus 1. No GCFs. Leading term that's not a 1. So we got to do the a times the c here. 25 times 1 is a positive 25. Factor pairs, 1 times 25 or 5 times 5. We're trying to add these to make a positive 10. 1 plus 25 is 26, 5 plus 5 is 10, boom, 5 and 5 works. We're going to have to give them signs. Let me pull the instructions back on screen. I'll scroll down eventually in case you missed something from A. And there's always the YouTube replay as well. For now, until we're in class. We're trying to make a positive 10. So if I choose these opposites, that would cancel out. If I choose these both negatives, that would make a negative 10. These both need to be positive. 5 plus 5 would make 10. So we go 25x squared. I'll leave a plus 1 at the end. But then we go plus 5x plus 5x. So once again, the middle term's been split in two. Two are the same, in fact. That's kind of cool. They can be same, they can be different, doesn't matter. And again, if you can make it this far, if you were able to make the selection of numbers and signs to make everything actually work, I guarantee this 4-term polynomial you can factor by grouping. GCF, GCF, GCF. For the first pair, 25x squared and 5x, there's a GCF of 5x. When you divide that out, 25x squared divided by 5x is 5x plus 5x divided by 5x is not nothing. Don't leave a blank there. It's 1. Now here's where things get interesting. This sign is a plus, so I guarantee this is a plus. But there is no real GCF between 5x and 1. You can't take any x's because the 1 doesn't have it. You can't take any numbers because the last number is a 1. Well, you can't take any non-1 numbers. So between 5x and 1, there's no big beefy GCF. But whenever that happens, you still have to take something. So you take a 1 out. They do have 1 in common. So take it out. It's not going to change much. 5x divided by 1 is 5x. Plus 1 divided by 1 is 1. This doesn't happen a lot, but it does happen. And check it out. 5x plus 1, 5x plus 1, they match. So here's our third GCF, the parentheses. So what do? We write the GCF first, 5x plus 1. Then we open a new parentheses. We mentally, physically cover up those parentheses above to see what goes in the next one. From the first bit, we have a 5x. From the second bit, we have a +1. Huh. Well, that's interesting. The two parentheses actually match. It can happen. You know what that means? What's 2 times 2? Yes, it's 4, but you could say it's 2 squared. What's 11 times 11? Yeah, it's 121, but you call it 11 squared. What's x times x? All you can do is call it x squared. Y times y is y squared. Anything times itself is itself squared. And this is usually how we want to write things at a pre-calc level. That's going to be very important for later. The 5x plus 1 times 5x plus 1 is still technically right, but this is a better format 9 out of 10 times. All right, let's do more. See. Let's see if I can get that on screen still. There we go. What do I have for C? 9x squared minus 5x minus 4. All right, no GCFs. Write down the brass tacks. Leading coefficient, it's not a 1. So go to the AC method. Positive 9 times the negative 4 would be negative 36. Again, I'm not just splitting up the negative 4. That would be a shortcut method if that 9 wasn't there, and that'd be cool. Factor pairs. 1 times 36, 2 times 18, 3 times 12, 4 times 9. About 6 times 6. 5 won't go in. And there we go. There's all of them. 1, 2, 3, 4, 5 options. Pick the pair that will subtract to make 5. 36 minus 1, 35. Nope. 18 minus 2, 16. Nope. 12 minus 3 is 9. Nope. 9 minus 4 is 5. 6 and 6 would cancel. Has to be subtraction because that was a negative. Give the 4 and 9 appropriate signs to actually combine to a negative 5. If you think it's a positive 9 and a negative 4, that would subtract to a positive 5. So go negative 9, positive 4. Here's a cool trick. The larger number will always share signs with this one, whether it's adding or subtracting. So we go 9x squared plus 4x minus 9x minus 4. The order you write the plus 4 and the minus 9 does not matter. Your work will look different in the middle, but you'll get the same answer in the end. So if you wrote minus 9x and then plus 4x, I guarantee you can still get it right. Maybe we'll do that to prove it. GCFs in pairs, because it's 4 terms. Between 9x squared and 4x, you're going to take out a GCF of, well, not much, just an x. 9x squared divided by x is 9x. 4x divided by x is a positive 4. This middle term, third term, excuse me, has a minus, so I probably need to take a minus out here. There's no real GCF between 9x and 4, so like last time, we just take out a 1, a negative 1, in fact. But that's going to change all the signs. Negative 9x divided by negative 1 is positive 9x. Negative 4 divided by negative 1 is positive 4. And looky, looky, we got a cookie. 9x plus 4, 9x plus 4, they match, making it the third GCF. So we write it first. We open a parentheses, and then we write everything else that was left over when we get rid of the GCFs. Get rid of Get rid of, I see an x minus a 1. There we go. Want to see what happens if you swap the order. Now you got to have the signs right. You can't do -4 and +9. I've just swapped the numbers directly. The GCF of the first pair is now a 9x. You open that up. 9x squared divided by 9x is x, minus 9x divided by 9x is 1. There is a bigger GCF here now. That's a plus this time as well. 4x and 4, we can take out a 4. Open up your parentheses. 4x divided by 4 is x. -4 divided by 4 is a -1. Matching parentheses. So we can take out the x minus 1 as our GCF. What do we see left over? A 9x and a +4. The exact same answer. It's just the parentheses are in opposite order, which does not matter. 7 times 5 is the same thing as 5 times 7. Give you one more minute to make sure you got all that. Do probably one more example. Sure. I'll do this in case anyone else was still writing. So we'll zoom out. Give you another 60 seconds. All right. Mix it up a little bit. 6x squared plus 7xy minus 5y squared. Uh-oh. Uh-oh. Don't worry about it. This isn't really going to change the game at all. We just got to be careful. That leading coefficient is not a 1. The fact that there's a y and a y squared in there doesn't change this at all. AC method. But don't involve the y squared in there. You're just taking the numbers. The 6 times the -5, which is -30. Factor pairs of 1 times 30, 2 times 15, 3 times 10, or 5 times 6. We're still subtracting to try and make a 7. 30 minus 1 is 29. 15 minus 2 is 13. 10 minus 3 is 7. Up, there we go. Trying to make a positive 7, so the bigger number should be positive. We're subtracting, so opposite signs, -3. Here's what happens. We leave the 6x squared alone in the front. We leave the minus 5y squared alone in the back. Splitting the middle term, this isn't just an x, it's an xy, so the middle terms need to both have an x and a y. So we go minus 3xy plus 10xy. You can't just give one an x and the other a y. Both have to have an xy. That way they'd be like terms if you were going to recombine them. Which you shouldn't. All right, GCFs in pairs. 6x squared and 3xy, there's a GCF of 3x. Can't take any y's out because the first one doesn't have any. Open a parentheses. 6x squared divided by 3x is 2x. Minus 3xy divided by 3x. The 3's are gone, the x's are gone, you're just left with the y. That middle sign is a plus, so this should be a plus. GCF. Between 10 and 5, we can pop out a 5. Between x, y, and y squared, we can take a y. You can't take any x's because this one doesn't have any. You can't take y squared because this only has 1. Open a parentheses. I'll bet you $1 million this is going to be 2x minus y. 10 divided by 5 is 2. X divided by no x's leaves it. Y divided by y cancels. Minus 5 divided by 5 is 1. Y squared divided by y is y. There we go. We have a matching GCF binomial. So we write that first, 2x minus y. We open a parentheses. And then what goes in the next parentheses? It's everything that wasn't what we just pulled out. The 3x and the plus 5y. There is our answer. So we're going to call it a day there. Next time what we'll do is we'll practice more with factoring, but I'm not going to do everything clustered. It's not just going to be all AC problems and all shortcut problems and all difference in sums of cubes and squares problems. We're just going to do a bunch of examples, and it could be any of those things. A might be a difference of cubes. B might be a shortcut method. C might be a difference of squares. D might be an AC method. We'll also get into the trial and error method very briefly. But again, I'm not really going to emphasize that method. Again, if you like it and know it, be my guest to use it. There's not really enough time to introduce it today. So before we head out, do we have any questions? And I've got everybody unmuted now in case anyone needs to speak. We will go back to having y'all kind of help me with examples every now and then at some point. But for now, it's just been more of a, I've got so much time and I want to get these things done. I wanted to have essentially all the factoring methods done before next class, because this is when you'll need to have seen everything to be able to do them on the fly in 1.5 for Math 161. All right, so no questions. Be on the lookout for whether or not this class is going to continue over Zoom, or if we will in fact go to in-person starting on Tuesday the 1st. I am hopeful that we're going to go back to in-person on Tuesday the 1st, but if we got a Zoom, we got a Zoom. Have a good day. Work hard, work on these problems. I did get a P.4 built the other day, in fact Thursday. I am going to start working on a P.5 right now, and maybe I'll have it up in, actually I already have something half built, so maybe I'll have that up in the next 10 or 15 minutes if you want to go ahead and start working on those. All right, have a good one, and we'll see you Thursday, everybody.